Okay, this is the notes for 2-7 proving segment relationships. You should already have this. If you need to write it down, you can pause this recording. Um, Yesterday we went through the ruler postulate that allows us to measure and the segment addition postulate. I'm going to go through things today, and sometimes I'll use the magic pen to highlight things because then it'll just erase itself. But sometimes when you're watching the video, if I want to point something out, it's a little easier for me if I'm actually writing on the smart notes, but I don't want to leave things. The segment addition postulate, you'll be using it today in the proofs that you're writing. My hint to you is generally that it's the little piece plus a little piece equal to the whole thing. And through the year, I'll give you that as a hint. When we write that statement in a proof like AB plus BC equals AC, it's the segment addition postulate. We're using an equal sign because we're talking about lengths being equal. Okay, so those are kind of the dynamics you want to remember. Today we'll use several of these properties of segment congruence, the reflexive property, the symmetric property, and transitive property. Remember, reflexive just says that something is congruent to itself. Symmetric is when we want to flip that congruence statement. So if we say that something is congruent to the second thing, then the second thing is congruent to the first thing. We'll use the transitive property. The first thing congruent to the second thing, and the second thing is congruent to the third thing, then we can say that the first thing is congruent to the third thing. First thing congruent to the third thing. So I'll be asking you those questions as we go through writing these proofs. You should have this handout, and we marked some things as congruent on here. I'm actually going to go to the page in my notes that has that. And so here it is. That way I have a little bit of room below. I think yesterday I told you if you wanted to cut that apart, that was up to you. I want you to notice also that this is given and this is given as an if-then statement above here. And just notice that the hypothesis is segment AB is congruent to segment CD, and that turned into the given information. And after the word then is the conclusion, segment AC is congruent to segment BD, and that is the proof statement. So if when you're doing homework, you're given an if-then statement to write a proof for, you know that the hypothesis is the given and the conclusion is the proof statement as we go. Yesterday in all hours, because this recording is for all hours, yesterday in all hours, we said that since segment AB was congruent to segment CD, we'd mark that on the picture. So it should be marked from yesterday. If not, go ahead and mark it now. If you remember, we always do this same first statement, and we'll switch that up a little bit in the next one. Would you tell me what to write as my statement and reason? Okay, we'll say segment AB is congruent to segment CD. And what is the reason for that? The given. That is just by the given. Now, that's AB and CD. That's what I'm starting with. When I look at this proof, I'm always kind of looking ahead to the proof statement. And I want to end up with segment AC and segment BD as I'm going through things. So when I look at segment AC and I want to introduce it to my proof, that means I want to say something about segment AC. Well, we just had the segment addition postulate. And do you agree that this little piece plus that little piece equals the whole thing? I need a head nod on that. We agree that that's true. So we can use the segment addition postulate, and that will introduce AC into our proof. Keep in mind the segment addition postulate used an equal sign, not as congruent to. Do you all agree with that as well? So before we introduce that, we want to say to ourselves, you know what? I really wish these were lengths equal to each other. I want everybody to find their 3 partial proofs that we wrote the other day. And I want you to point to the one that you think is related to this problem right here. Find those partial proofs and point to the one that you think is related to this one that we're talking about. I just want to look at it. Okay, and as we're looking at those, the little partial proofs that are over here, as we're looking at those, I'm seeing lots of people who are pointing to it. If you're not, I believe it's the first one of those partial proofs. And give me a head nod if it's identical to this, actually. It is identical to this one. And so would you read to me what I'm going to write as statement 2? And I'm going to convert this segment AB congruent to segment CD into things that are equal. What am I going to write? AB equals CD. And what's the reason for that? Of what kind of segments? Definition of congruent segments. So definition congruent segments. So I want to kind of say why I did that again. I did that so that when I'm talking about things like the segment addition postulate, I'm looking at lengths that are equal. So I want these 2 lengths to be equal more than I want to have them as segments that are congruent. So I did that conversion. I still don't have my AC in here yet that I want. So now that I've kind of cleaned that up so that it's equal, now I'm going to go back to my thought on the segment addition postulate where the little piece plus the little piece is equal to the whole thing. And I've talked about it enough that we're kind of thinking over here, it's probably going to be that segment addition postulate. And so when you tell me that step, that's what you're going to tell me is the step. Shelby, can you tell me this little piece plus this little piece equals that whole thing? And do you remember what the reason is for that? It's on this handout for this section. And what is that called? The segment addition postulate. Segment addition postulate. And notice I'm doing a little bit of abbreviating as I go. So that makes me happy to this point that I know in the end of my proof I end up with segment AC, and right now I have put an AC in there, okay? So now it would be super nice if somehow, since that AC is right there, it would be super nice if I could somehow magically or by rules change this into CD, because those are the 2 things that I want to have equal. So now I'm just going to look at this and I'm going to say, oh, you know what? If I look up here at step 2, give me a head nod if you agree that I have AB equal to CD, right? And could I replace the AB down here in 3 with that CD? Could I make that replacement? And when I replace something with something that's equivalent, what's that called? Substitution. And so tell me the next step, and let me just make sure I'm writing in green. So we're going to replace this with that. So go ahead and tell me what to write. Nope, just AC. I know what you're doing there, but all I'm doing is replacing this AB with something that's equal, and that's CD. And so I'm just replacing that AB with CD, because then I'm going to notice something about when I add those two together. And just remind me what that was called when I replaced one thing with something equivalent. Substitution. Substitution. So I've got substitution going on there as that step. Now, I want to look at my picture again. And now, think about what these two things make on the picture. I've got CD right there. I've got BC right here, and I'm adding those together. Well, if I look at this picture, if I add this little piece plus this little piece, give me a head nod if you agree that it's that whole thing. Do you agree that that little piece plus that little piece is the whole thing? I need a little bit more affirmative approach there. If I add this piece plus that piece, I get this whole thing. C is between B and D, so the segment addition postulate says if I add this little piece and that little piece, then I get that whole thing. I'm going to write it in that way, and I'm just going to write that one. It gets a little hard for me to see everything. So statement 5 is, and I'm going to write it like this one, just so that it's easier for me to manage as I go through. I'm going to say CD plus BC is equal to BD. And that is going to be the segment addition postulate. When I'm looking at the picture and I'm saying the little piece here plus the little piece there is equal to the whole thing. So this is segment addition postulate. And I shortened it up a little bit from that last time. Now I want to say, oh, I am super happy, because do you agree that the two things I just underlined are exactly the same, right? And one of them is equal to AC, one of them is equal to BD. So can I replace, and I'm kind of thinking about my proof statement, I want BD over there. Can I replace this added stuff together with AC? Am I allowed to do that, do you think? Give me a head nod for that. Yep. And so when I replace something, I know what that's called. Would you tell me what I'm going to write when I replace this stuff with that? AC equals BD. And what's the reason for that? When I replace something with something equivalent? Substitution. Substitution. Now look carefully. On mine, I can't see the proof statement. Give me a head nod. Is that step 6 identical to the proof statement? Is it identical? No, it is not identical. But is it super close? Yes. Can you change it into the proof statement for me? And think about or look at your partial proofs. Do you have a thought on what the reason is for that? Definition of congruent segments. Definition of congruent segments. So notice we use that definition of congruent segments twice in this one. We used it to take off the is congruent to, and then we used it again to put it back on. So remember, these are our first proofs we're writing. We don't have a whole lot of tools to do that with. And so we're not asked to do really involved proofs, but they're involved enough for us. So we're using that segment addition postulate. We're using substitution quite a bit. In our next one, we're going to try to use transitive as well. And some of these other things. So that's that one. Now, the next one actually has words written with it, and I just gave you the proof format, but I will read through this example. It says, Jamie is designing a badge, and I'm going to use that magic pen a second. There we go. Jamie is designing a badge for her club. The length of the top edge of the badge, so it's right there, is equal to the length of the left edge of the badge. So those two are the same. The top edge of the badge, which is right here, is congruent to the right edge of the badge. And the right edge of the badge, which is right here, is congruent to the bottom of the badge. So it tells us to prove that the bottom edge of the badge, which is right here, is congruent to the left edge of the badge. Give me a head nod if you think it is congruent, you know. And this should be pretty straightforward. Can you see in your mind why we might use transitive? You know, this is congruent to that, that is congruent to the next thing, and so on. Now, if you remember, I told you it's always correct to put all the given at once, right? And we can just put it all there and go on. As we get a little bit more confident, sometimes we want to just put some of the given and then use that and then put the rest of the given. So that's what I'm going to model in this one. If all of the rest of you always in your proofs on this homework put all the given first, that is absolutely fine. But I'm going to kind of just try to get us to kind of think a little bit ahead of things. And I actually think I'm going to use this slide because it'll be a little bit easier for me. Yours is set up for statements and reasons. I'm going to set mine up. Oh, but not with the magic pen. There we go. I'm going to set mine up with statements and reasons. So I can put it on this slide. I like this slide a little bit better for my spacing. Now, I'm going to go back to the magic pen because I'm going to ask you to just look at these things. As you look at those, that's the given and the proof. As you look at those, do you see there's a mixture of lengths equal and segments congruent? Give me a head nod if you do. And do you see that there's more of one kind than the other kind, right? So when that happens, and we've already looked at the picture, we know I'm not going to use the segment addition postulate like I did before. It might be most convenient to just change them all to be the same. Does that make sense to you? To change them all to be the same. And since more of them are is congruent to, I'm going to change them into is congruent to. Does that make sense to everybody as I look at that? So there are three things in the given. I'm only going to write that very first one and then make that change. And then I'm going to write the other two after that. And you're going to help me as I go. So do you know what the very first thing is we're going to write? It's going to be that. So go ahead and tell us. And what is the reason for that? WY equals YZ, and that is the given. Now you're going to know why we wrote those partial proofs. If you have to look at your partial proofs, go ahead and look at them. If you know what is happening there, give me a head nod if you know what you're going to do next. So if you don't know what you're going to do next, you're looking at those partial proofs. Tell me what my next statement's going to be. Segment WY is congruent to segment YZ, so I'm changing it back or to congruent segments. And what's the reason for that? Definition of congruent segments. And so I am doing that specifically just because all the rest are, and you know, this one wants to be like everybody else. Just like, you know, a lot of times we do. So that's all I wanted to do. I just wanted to get it on my paper, and I wanted to change it to is congruent to. Now I'm going to put in the rest of these. Alexis, go ahead and read these to me, and then tell me why we're putting them in our proof. That'll be statement 3. And So segment YZ is congruent to segment XZ, and segment XZ is congruent to segment WX. And what's the reason for that? The given. And so now I want you to notice this. On this one, I use 2 lines, and I'm going to put this up a little bit because I don't need to see my given anymore. I have it all on my proof as I'm going through things. But I use 2 lines here. So when I do statement 4, and I'm just going to use my magic pen a second. When but I didn't grab it. I'm going to use my magic pen. When I write statement 4, I want to make sure that they're horizontally lined up, right? So I don't want to put my reason for way up there. I'm going to put it down here where I can see it more easily. So now I already kind of said if segment YZ is congruent to segment XZ, so I'm going to say the first segment is congruent to the second segment. And then look, segment XZ, which is the second segment, is congruent to the third segment. Can you think in your head of what 2 segments have to be congruent then? If the first segment is congruent to the second segment, and the second segment is congruent to the third segment, what segment has to be congruent to what segment? Do you know which ones they are as you're looking at that? Nolan, go ahead and tell me what 2 segments have to be congruent. And I'm just going to say it one more time, and then you're going to tell me. So the first segment is congruent to the second segment. The second segment is congruent to the third segment. So what am I going to be able to write in 4? Segment YZ is congruent to segment WX. And look back on that handout for this section and point to which thing you think it is the reason on that one. Yep. Go ahead and tell me what it is. The transitive property of congruence. So transitive property of congruence. So if the first thing is congruent to the second thing is congruent to the third thing, then the first thing is congruent to the third thing. Now, I'm feeling sort of happy because I feel like in my proof statement, which is right here, I want segment WX to be congruent to segment WY. And do you agree that I have WX on there, right? Give me a head nod if you agree. I've got WX on there. I would like to end up with, I need WY on here as well. Do you agree with that? So I want to look back through my stuff, and I want to say, okay, right there is segment YZ. I would like to somehow replace that segment YZ with WY. And I'm going to look back to step 2. What do you notice on step 2? Segment YZ is the same as segment WY. So can I replace this segment YZ with segment WY? Give me a head nod if you think that I can. So I want you to do that for me. And so in place of segment YZ, you're going to read this one, Shelby, and then just the rest of this. So you're replacing that into right there. Segment YW is congruent to segment WX. And remind me what that reason is when you replace something with something congruent. Substitution. Substitution. Now, next question. Look at the proof statement. Is this identical to the proof statement? No, it is not. Is it super close? And think about how I can make that change. Cole, can you think about what I'm going to do to change this to that? Okay. Can you tell me my statement then? And this is on that handout that we have for this section. Do you know what that's called when we flip them? Go ahead and say it. Symmetric property of congruence. Now, am I exactly to my proof statement? Yes, I am. So I have everything done that I need to have done there. Okay. Now I want to give you some time in class to set things up. So the next thing you're going to do is take a few minutes, write your summary and your questions, write your level of understanding at this point. Hopefully it's gotten a little better from the beginning of the hour, but I know these are, or beginning of the lesson, but I know these are hard. Once you're done with your questions and summaries, you are going to work on homework 7, and I am here to help answer your questions and kind of get you going on things. Make sure you also glue in any handouts that you need to.